All right. And problem number one does say the graph of f shown has a vertical asymptote at x equals 2 and x equals 6. You want to find the following limits. Use infinity or negative infinity when appropriate. And of course, if the limit doesn't exist, you can just say does not exist, or in short, DNE. So in problem number one, part A, this down, we got the limit as x approaches 2 from the left of the function f of x. So in this graph, let's see, here's 2 right here. So as we come from the left of 2, the graph will be going towards, and you can see it goes downward, it goes towards negative infinity. Okay, because it's not going to a finite value, so it's just going to negative infinity. Okay. Now part B says the limit as x approaches 2 from the right of the function f of x. So we look at this graph here. Here's 2, and if we come from the right of 2, this graph is going where? Positive infinity. Okay.
One quick question: like, how can you tell where the direction of the infinity going? Like, you find
Negative infinity goes downward.
I know I'm talking about like you find 2 on the x-axis and then you go like right.
From the left of 2.
Okay.
Yeah, left of 2, because that's what that minus sign is for. 2 from the left, meaning from the left of 2. And then again, with the 2, with the plus sign means 2 from the right. So if we're coming from the right of 2, it goes up in this direction. Okay, any questions? Now part C is a limit as x approaches 2 itself of f of x. Now if it's just approaching 2, that means what? Does not exist. Because notice on the left of 2 is going to negative infinity, and to the right of 2 is going to positive infinity. It has to be going in the same direction here in order for that limit to exist. In this case,
I'm sorry, like I'm just trying to visualize that on the graph, and I'm just lost.
Okay, here it is to the left of 2. Here's
So
2.
Positive 2 on the x-axis, right?
Yeah, on the x-axis.
Okay, so to the left is going infinity, or to the left.
Yeah, because if you follow the graph, if you come from the left of 2, right here, this graph is going down to negative infinity, okay, going in the downward direction. It's not going to a finite number.
Okay.
Okay.
So it goes either up or down.
Yeah.
Okay.
And in this case, to the right of 2, here's everything coming from the right of 2. You can see that this graph is going upward.
Oh, okay, I got you.
To positive infinity.
Okay, perfect.
All right. Now in this case, since to the left of 2 is going to negative infinity, to the right of 2, bless you, it's going to positive infinity. It's going in 2 different directions here. So when we let x approach 2 for the limit of f of x, does not exist. Okay? Does not exist. All right. Questions about parts A, B, or C? Okay. Now part D is the other vertical asymptote, and that's at 6. So if I take the limit as x approaches 6 from the left of the function f of x, okay, take a look. Here's 6 right here. As we come from the left of 6, Notice where this is going,
Oh,
upward. So it's got to be going to
positive.
positive infinity.
Oh, so we look at that, the curve, or the U shape.
Yeah. And sometimes it helps to know if we come in from the left of 6 right here, look where it's going,
Okay.
positive infinity. And then in part E, the limit as x approaches 6 from the right. Of f of x. Okay. We're coming in to the right side of 6. So that means this is going where?
So it's positive.
Positive infinity. And based on what we got for parts D and E, part F is the limit as x approaches 6. Infinity. Because notice on the left is going to infinity when we come in from the left of 6, and also is going to infinity as we let x approach 6 from the right. So they're both going in the same direction, so that means at x, as x approaches 6, the limit of the function is going to infinity. Okay? Are there any questions about problem number 1? Just using that graph to find limits. Okay, problem number 2. Determine the limits of each of the following, and also use D and E for does not exist if that limit doesn't exist. So, starting with part A of number 2, here we got the limit as x approaches 0 of x cubed minus 2x squared divided by x squared. And in that problem, you're given a hint to simplify the expression inside the limit. So that means here, I'm going to bring over the limit notation, the limit as x approaches 0. Let's try to simplify this expression by finding a common factor for x cubed and x squared. That'll be x squared. So if I factor out the x squared, this one will have x cubed divided by x squared, that's x, minus 2x squared divided by x squared, be 2. All that's divided by x squared. Now if I simplify this, as you can see, the x squares will divide out. So all I'll be left with is the limit as x approaches 0 of x minus 2. And in this case here, I have a linear function. I can use direct substitution here. Just replace this x with that 0. So it'll end up being 0 minus 2, which is negative 2. So the limit as x approaches 0 of x cubed minus 2x squared divided by x squared ends up being negative 2. Okay. Questions about part A? All right, now let's say we have the limit as x approaches infinity of 9x cubed minus 2x squared plus 3x, whole thing's divided by negative x cubed minus 2x plus 7. Okay. Now what I would do here with this limit as x approaches infinity is divide every single term in the numerator and the denominator by the highest exponent of my denominator. So here the highest exponent in the denominator is 3. So I'll divide every single term by x cubed, both in the numerator and the denominator. So I have the limit as x approaches infinity, of 9x cubed divided by x cubed minus 2x squared divided by x cubed plus 3x divided by x cubed. And I'll do the same thing in the numerator. Negative x cubed divided by x cubed minus 2x divided by x cubed plus 7 divided by x cubed. Then the limit as x approaches infinity of, if I divide 9x cubed divided by x cubed, that's 9, minus 2 of the x squares, 2 of the x's will divide out. I'll be left with an x in the numerator, so it'll be 2 divided by x, plus 1 of the x's will divide out. I'll be left with an x squared in the denominator. So it'll be 3 over x squared. Oh, that's going to be divided by, let's see, negative x cubed divided by negative x cubed divided by x cubed, that's negative 1. 1 of the x's in x cubed divides out. I have 2 over x squared plus, and this would just be 7 over x cubed. Okay, now let's go ahead and take the limit as x approaches infinity. For that 2 over x, if I let x approach infinity, that 2 over x will be getting closer and closer to 0. Same thing for the 3 over x squared. That's going to get closer and closer to 0. And then for 2 over x squared, when I take its limit as x approaches infinity, it'll get closer and closer to 0. And as we let x approach infinity, the 7 over x cubed also goes to 0. And of course, the limit of a constant is a constant, so that means I have a 9 over negative 1 that ends up equaling negative 9. So the limit as x approaches infinity of 9x cubed minus 2x squared plus 3x divided by negative x cubed minus 2x plus 7 ends up being negative 9. Okay. Are there any questions about problem number 2, A or B? Okay, on to part C. Now this one, we got the limit as x approaches negative infinity of 3x to the 17th power. All right, when I take that limit, I can pull the 3 out in front, so it'll be 3 times the limit as x approaches in negative infinity of x to the 17th power. So I know 3 times. Let's see here. If I take negative infinity and it's to an odd power, it's going to be what? Negative. And it'll just be negative infinity. And 3 times negative infinity ends up being negative infinity. It's just going to be going to negative infinity 3 times as fast. So the limit as x approaches negative infinity of 3x to the 17th power would be negative infinity. Okay. Questions about part C? And part D is the limit as x approaches negative infinity of 5x to the 7th minus 6x to the 6th plus 1. Now, since I have a polynomial function, what I'm going to focus on is this leading term, that 5x to the 7th. So if I take the limit as x approaches negative infinity of 5x to the 7th, I can pull the 5 out in front of the limit as x approaches negative infinity of x to the 7th. Well, again, negative to an odd power, that's going to be what? Negative infinity. And of course, 5 times negative infinity would be negative infinity. That's all there is to it. Okay, so are there any questions about problems A, B, C, and D of number 2? Okay, number 3. I wish everyone had this because okay. All right, number 3. Evaluate the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x for each function, and then give the horizontal asymptote of the function f, if any. So here we've got f of x is equal to 6x squared minus 8x plus 7. Now that's divided by 2x squared plus 1. Use a different color. Okay. So here we're just finding the limit. We're going to start with finding the limit as x approaches infinity of the function f of x, which is, of course, a limit as x approaches infinity of 6x squared minus 8x plus 7 divided by 2x squared plus 1. Now, just like I did in problem number 2b, we're going to divide every single term in this by the highest exponent for x in the denominator. In this case, it's going to be x squared. So 6x squared would be divided by x squared, minus 8x would be divided by x squared, plus 7 divided by x squared. And then in the denominator, the 2x squared will be divided by x squared, plus 1 divided by x squared. Then we'll simplify. So if I take the limit as x approaches infinity of 6x squared divided by x squared, that's 6, plus one of the x's divides out with the x squared, leaving me with 8 over x, plus this will just remain as 7 over x squared. All that's divided by 2x squared divided by x squared would be 2, plus and that 1 over x squared would just be 1 over x squared. Now we can take the limit as x approaches infinity of each of these terms. That means if I let x approach infinity, 8 over x goes to 0, 7 over x squared also goes to 0, and 1 over x squared goes to 0. So that means here the limit of a constant is a constant, so it'll be 6 over 2. That ends up being 3. So that means here the limit as x approaches infinity of f of x would be 3. And then we also have to do the limit as x approaches negative infinity. But if I divide every single term by x squared, I'm going to end up getting this right here. And then when I take the limit as x approaches negative infinity, these terms right here would go to 0. So I'm still going to have 6 over 2, which is 3. Okay, and notice as we let x approach infinity, we end up with 3. And as we let x approach negative infinity, it also ends up 3. So that tells me this will be my horizontal asymptote. And it's the equation y is equal to 3. Because a horizontal asymptote is a horizontal dotted line going through the y-axis at that value. So y equal 3 is your horizontal asymptote. All right, questions about part A of number 3. Okay, now part B is the function f of x is equal to 41x to the 6th plus 2x squared divided by 16x to the 5th minus 2x. So here we want to find the limit as x approaches infinity, and then the limit as x approaches negative infinity. So here we've got the limit as x approaches infinity of 41x to the 6th plus 2x squared divided by 16x to the 5th minus 2x. Now in this case, we divide every single term in the numerator and the denominator by the highest exponent in the denominator. Here we're going to be dividing by x to the 5th. And then 2x squared will be divided by x to the 5th. The denominator, 16x to the 5th, will be divided by x to the 5th minus 2x divided by x to the 5th. And then we simplify this. Let's see, the limit as x approaches infinity of, if I divide 41x to the 6th by x to the 5th, I would get 41x. And then 2x squared divided by x to the 5th, that's going to be 2 over x to the 3rd. And then 16x to the 5th divided by x to the 5th would be 16. And then this is a minus 2x divided by x to the 5th. 2 over x to the 4th. Well, we can see here if we let x approach infinity, the 2 over x cubed goes to 0, and 2 over x to the 4th also goes to 0. So I'm left with the limit as x approaches infinity of 41x over 16. Now in this case here, that 41 over 16, I can just bring that over. But here x goes to infinity, so that means this x will be going to infinity. And 41 over 16 times infinity would be infinity. So as x approaches infinity, 41, well, the function will be going to infinity. Now, as we let x approach negative infinity of this function, but this one's going to be less work here because of the fact if I divide every single term in this by x to the fifth, like I did up here, I'm going to end up with 41x over 16. So this means here that the limit, and this should be negative infinity, by the way, so the limit as x approaches negative infinity of this will end up being 41x over 16. And then, let's see, 41/16, replace that x with that negative x. What's going to happen when I multiply 41/16 times negative infinity? Negative infinity. All right, so as you can see here, as we let x approach infinity, it's going to positive infinity. But if we let x approach negative infinity, it's going to negative infinity. So that tells me right there that this function has no horizontal asymptote. Is it 1C? Because at infinity, the function is going to positive infinity, but at negative infinity, it's going to negative infinity. So in this case here, there is no horizontal asymptote for the graph of that function. Any questions about problem number 3? A or B? Okay, problem number 4. Is using the continuity test to determine if the function is continuous at the indicated value. Okay, so here's what the graph looks like. So in problem number 4, part A, we want to know if the function is continuous at x is equal to 3. There are 3 different things that you have to find out that all must be satisfied in order for it to be continuous at that value. Like for the first one, f of 3 must exist. F of 3 has to exist. So if you look at the graph, what's the value of the function at x equal 3? 1, because here's 3 right here. And of course the dot there tells me that it's at 1, so f of 3 is equal to 1. Now part B, the limit as x approaches 3 of that function must also exist. And it's got to be on the left and on the right. If we come in from the left of 3, where is this graph going, getting closer and closer to? To 2. Now, what about as we come in from the right of 3, where is this getting closer and closer to? 1. We got from the left it's going to 2, but from the right it's going to 1. Does that function exist? Does that limit exist or not? It doesn't. Does not exist. Does not exist. Okay? So, to answer that question, is it continuous? Well, let me remove this. So to answer that question, is it continuous at x equal 3? No, because it violates number 2. The limit doesn't exist. So that means that f of x, the function itself, is not continuous. At x equal 3. Okay. All right, questions about part A. All right, now part B, is the function continuous at x equals 5? Well, let's find out what f of 5 is going to be to see if it exists. Okay, using a graph, what's the value of x? What's the value of the function when x equals 5? 3. Because there's a point right there, and it's at 3, so f of 5 is 3. And then next is a limit as x approaches 5 of f of x. Okay, the limit on the left side of 5 and on the right side of 5 has to be the same. As we come in from the left of 5, where's this value, the y value, getting closer and closer to? 2. 3. And to the right of 5, where's it getting closer and closer to? 3. All right, now, we ask ourselves, is f of 5 the same as a limit as x approaches 5 of the function f of x? Are they equal? Yes. So that means here that the function f of x is continuous at x equal 5. Okay. Are there any questions about problem number 4? Because you have to use that continuity test. You want to find out what f of that value is if it exists, and then find the limit as x approaches that number, and find out if it exists. And of course, f of that value must be equal to the limit as x approaches the value of that function. They got to be the same for it to be continuous. All right, number 5. Determine the intervals in which each function is continuous. All right, so in part A, we got p of x is equal to 7x to the 6 plus 4x squared plus 9. Now this one should be easy because of the fact that it is a polynomial function. Any x value that you assign to it, you're always going to get a value of f of x for it. So the interval on which it is continuous would be what? What do you think would be the interval for this? It's a polynomial function, so it has to be from, negative infinity to infinity. Okay, it's continuous everywhere on that number line. Now part B, we got f of x equals 4 divided by x squared minus 25. All right, so now you have to find out what values of x that would give you a 0 in the denominator and give that answer in interval notation. Probably the best way to find out would be to set the denominator x squared minus 25 equal to 0. And can we factor x squared minus 25?
Yes.
Okay, as?
X plus 5 times x minus 5.
Okay. And then we set each binomial factor equal to 0. So that means x plus 5 equals 0. x minus 5 is equal to 0. And then for x plus 5 equals 0, if we solve for x, that means x is equal to negative 5. And then for the x minus 5 equal to 0, we add 5, x is equal to 5. So at negative 5 and positive 5, we would get a 0 in the denominator. Now, of course, this is not necessary for you to do this on the exam, but if the number line helps, you can do that. So here we got negative 5. Let's say 5 is over here. We know we're going to get a 0 in the denominator for negative 5 and for positive 5. And any x value less than negative 5 would work. Any x value in between negative 5 and 5 would work. And any x value greater than 5 would work. So the function is continuous on this interval. Going from left to right will be from negative infinity to negative 5, or from negative 5 to 5, or from 5 to infinity.
So what happens to that 4 in the numerator?
Nothing. Doesn't matter. Because it could be anything up here. We just want to find out what values of x that would give you a 0 in the denominator. Okay. Any other questions? Okay, number 6 is the use of the intermediate value theorem. Now, we pretty much talked about this one in section 2.6. We're going to use that intermediate value theorem to show that the equation x cubed plus x plus 3 equals 0 has a solution on the interval negative 2, 1. And then use your graphing calculator to find all the solutions to the equation on the given interval. Okay, now, let's see if we can answer some questions here. This part on the left-hand side would be your f of x. This 0 is going to be L. Okay, because we did talk about the intermediate value theorem where f of x is going to be some limiting value of L. So, I need to find out the interval on which this function f of x equal x cubed plus x plus 3 is continuous on. Well, this one's easy because it's, again, a polynomial function. So it's got to be continuous on what interval? Negative infinity to infinity. So it's continuous everywhere. Now, here's the next thing I'm going to do here. Find the values of each endpoint. Each endpoint.
How do you know if something's a polynomial?
Well, there's no variable in the denominator. You're not going to find a variable in our denominator. There's no denominator here with a variable in it. Okay. Okay. And usually with a polynomial function, it has no restrictions on it. Okay. All right, so now we're going to find the values of each endpoint. Now, my endpoints are, excuse me, -2 and 1. So I need to evaluate what f of -2 is and what f of 1 is. Okay, and this is what f of x is, so I'm going to replace every x with those values here, starting with -2. So here's what I'm going to have, -2, and that's cube, plus x, which is -2, plus 3. And if I simplify this, let's see. I'm cubing a negative, so that's going to be negative. And then 2 cubed will be 8, so it'll be -8. And then minus 2 plus 3. So what's -8 minus 2 plus 3 equal to? -7. And then for f of 1, simply replace each x in that function with 1. Well, 1 cubed is 1 plus 3 is how much? 5. Okay. Now, here this is equal to 0. And I know what f of -2 is and f of 1 is. That's -7 and 5. Is this 0 between -7 and 5?
Yes.
Yes, it is. So that means that the intermediate value theorem can be used, okay? Because this right here has to be between these two numbers, -7 and 5, which it is. Now, the next thing is using the graphing calculator. This is where we're going to find the x value such that f of x is equal to 0. Okay. So here's what we're going to do. All right. Using the graphic calculator, we're going to go to y equal to, and I'm going to clear these equations out. If I can do that. So what I'm going to do in y1 is enter what f of x is, which is x cubed plus the x plus 3. So here I'm going to press xt theta n for the x, then the hat key, and then the number 3 for the exponent of x cubed. Using my right arrow key to get out of the exponential part, then plus xt theta n again for the x, plus 3. And then use my down arrow key to go to y2. I'm going to enter what L is, which is 0. Okay. And then I'll do zoom 6. Okay. And in this case, this is what the graph looks like. And of course, the y equals 0, that's the x-axis right here. Okay, so I'm trying to find out the intersection of this. So here's what I'm going to do. Press second and graph. No, take that back. Second trace. Second trace for the calculate menu. Then I'm going to select number 5 for the intersection of those two. So if I select number 5, I do get first curve, which is this. What I'm going to do is use my left arrow key to put the cursor on top of that point of intersection, and then hit enter. The second curve was y equals 0, as you can see in y2. The third would be the guess, and then hit enter again. You'll get your point of intersection. And if I was to round this off to 3 decimal places, this will be x is equal to -1.213. Okay, so that's what they were looking for here.
I didn't get none of that on my calculator.
Didn't? Well, let me see what.
I got a TI degree in my
Okay.
Yeah, I just deleted the first part, so I did x to 3 plus.
Plus x plus 3
got the right graph, but then when I did second trace,
Intersect. Put the cursor on top of that, x-axis. Okay. Is one on that point of intersection, and then hit enter 3 times.
okay. All right, thank you.
All right, any other questions?
It would be a negative, right? -1?
Yeah, negative 1.213, thank you. Okay. All right, any questions about using the intermediate value theorem to find out the value of x where f of x is equal to 0? Okay, now number 7. This is in section 3.1, where you had to use the definition of a derivative to find f prime of x of the function. And I would expect for you to use that definition. F of x is equal to 3x squared plus 3x. And if you recall, the definition of the limit, of the derivative is this. Let's see, f prime of x. That will be the limit as h approaches 0 of f of x plus h minus f of x. The whole thing is divided by h. Okay, so that means here f of x plus h, every x in this f of x function will be replaced with the x plus h. So that means I'm going to have 3 times. The x will be replaced with x plus h, and that's squared, plus 3 times. Again, that x will be replaced with x plus h. Okay? And then minus what f of x is. And I'm putting the 3x squared plus 3x in parentheses because the whole thing is being subtracted from f of x plus h, all divided by h. And then we simplify the numerator. So I'm going to bring down the limit as h approaches 0, 3 times. Let's see, that x plus h quantity squared, if you have to do that off to the side, and write as x plus h times x plus h, and then use that FOIL method, which is x times x, x squared. The outer x times the h would be plus xh. The inner h times x would be another plus xh, plus the last times the last h times h, h squared. So here we have x squared plus, there are 2 xh's, so it'll be 2xh plus h squared. So that's what x plus h quantity squared would be, x squared plus 2xh plus h squared. And then plus, distribute the 3 over the x plus h, this will be 3 times x, or 3x, plus 3 times h, 3h. And then that minus sign will make the 3x squared a minus 3x squared. The minus sign makes a plus 3x minus 3x. That whole thing will be divided by h. And now the limit as h approaches 0. Let's see if I can distribute that 3 over the x squared plus 2xh plus h squared. 3 times x squared would be 3x squared, plus 3 times 2xh would be 6xh, plus 3 times h squared would be 3h squared. And everything else I'm just going to bring down. That all this would be divided by h. Any term that doesn't have an h in it should go. Like 3x squared and minus 3x squared, that's gone. 3x and a minus 3x, that too is gone. So here the limit as h approaches 0 of 6xh plus 3h squared plus 3h. Whole thing is divided by h. And then the next step would be to factor the numerator. What can be factored out of that numerator?
H.
The h. And notice I'm bringing down this limit notation as h approaches 0 on each line. Okay, so here, factor out the h. This will be 6x plus 3h plus 3 divided by h. And what can be divided out in this problem? The h. H is divides out. I'm left with the limit as h approaches 0 of 6x plus 3h plus 3. Now we can take the limit as h approaches 0 of this. Okay, so as h approaches 0, this 3h is going to be going to 0. So I'm going to end up with 6x plus 3. And this is what f prime of x will be. Okay. Let me zoom out of this, because I want you to know that you do have to bring down this limit notation on each line when you're doing the algebra, because you have not yet taken the limit. You do that at the tail end. Okay. Are there any questions about problem number 7? And you have to use the definition of the derivative that was discussed in section 3.1. Now, problem number 8, A, B, and C, you can just use the properties of derivatives here. So in 8a, we got f of x is equal to negative 6x to the 5th. And we want to find out what f prime of x is. Okay. Now we can use the power rule to take the derivative, and also that constant multiple rule as well. So here we bring down that constant of negative 6. The derivative of x to the 5th, we bring down the exponent of 5. Copy the x over to the 1 less power, which is 4. And then simplify. So this ends up being negative 30 x to the 4th from negative 6 times 5. That's negative 30. And then bring over x to the 4th. Okay, questions on part A? Okay, part B is f of x is equal to 8x to the 6 minus 22x plus e to the 3rd. Okay, and I want to find out what f prime of x will be. So what do you think f prime of x will be for this?
48x to the fifth.
Okay. 48x to the fifth. What about
Then negative 22.
when it's 22? And what's the derivative of e cubed? 0. Because e to the third is a constant. And the derivative of a constant is 0. So f prime of x for that function would be 48x to the fifth minus 22. Okay. Questions on part B? Now, part C, we got g of t is equal to 12 times the square root of t. Okay, so g prime is this. Bring down the 12. Who remembers what the derivative of the square root of t?
1 over 2 to square root of 2.
Right. 1 over 2 square root of t. Okay. That was something that I showed you when I was doing the definition of the derivative and how to get the derivative of y equals square root of x, which is going to be 1 over 2 square root of x. But here it's just a t, so it'll be 12 times 1 over 2 square roots of t. And if I simplify this, this 2 goes into 12 6 times. So this ends up as 6 times 1, that's 6 over the square root of t. Okay. Questions on number 8? And let's see, number 9, I'll do that over here. It says here find f prime of x, f double prime of x, and f triple prime of x. And we have the function f of x is equal to 4x cubed plus 9x squared plus 3x. And these deal with higher order derivatives here. So if I take the first derivative of that function, what would I get?
12x squared.
Okay. And then
Plus 18x.
plus 18x plus 3. Okay, so that's the first derivative. And you have to know the first derivative in order to take the second derivative. Okay? Because the second derivative is the derivative of the first. So what would be the second derivative be? Or f double prime of x?
24x plus 18.
24x plus 18. And then finally, f triple prime of x,
24.
just 24. Okay. Any questions about higher order derivatives for number 9? Or are there any questions about what will be on exam number 2? Okay.